So I prefer that you ask questions during the talk, if you can. I'm not going to. So I'm academic. I come from Tel Aviv University. Actually, I've been in Imperial many times. I have many colleagues here. I'm also a visiting researcher at VMware. And also we are starting a company called Certora. I'll tell you a little bit about it. So the business that we are interested in is software verification. This is an old and mature area. The idea is that the programmer has to define what is the required property, and then we have a mechanism for formally proving that the code does what it's supposed to do. And you can ask why verify a smart contract. It's probably an obvious question in this crowd. By the way, how many of you are coders? Maybe you can just raise hands. Good. So it's really hard to get the smart contract right. And there are, even though smart contracts are kind of simple and small program, it's hard to get them right. So this is the famous DAO bug that you probably heard of, that somehow there is a contract, that, and I will talk about it a little bit later. So this is a kind of a very, very simple bug that actually you can do a attack. There's other kind of problems, like this is another kind of bug which happens when you updated a contract, and so on and so forth. And actually, interestingly, just recently, this is another case, and actually very similar to the DAO, where actually these bugs happen. And all of these bugs, they are costly, okay? And they really lead to loss of money. But more than that, they are kind of a barrier to trust, because if you want to use the blockchain and you see these bugs, they're actually kind of a barrier to trust. So, of course, software verification is an old topic, and getting software right is always hard. But what happens usually in traditional software, we get software right by evolution. The first version is kind of not so okay, but then the next version becomes better and so on. But in the case of blockchain, this is impossible, because the moment you upload the contract, it's immutable. So you really have to get it right from the start, which is very hard. And the slogan that you say is the code is the law. So if you have wrong code, you have wrong law. And unlike transactions which are done by the bank or other, you cannot revert transaction. Look what happened with that. Once you have a bug, it's actually the money is lost. So the standard currently, which is I guess kind of a best effort, is the idea of auditing or code review. That's lovely. It's very important. You go and you audit the code and you check its correctness. And this procedure is very useful. It can find bugs and it can find problems. But it's expensive and it actually misses many bugs. And it's not surprising. It's like looking for a needle in the haystack. There are so many behaviors in the program, so actually finding that, and we can show you that we run our tool after the auditors and we find bugs, which is not surprising, because the procedure is not exhaustive. Another thing to notice about auditing, that auditing actually has decentralization, because you ended up actually relying on the auditor. If you have a good auditor, it's good, but and there are very few good auditors actually. So you actually make this, you have decentralization. So what we want to do in program verification, and this has a huge history, actually many of it starting in the UK, that basically we want to take the system on one, we want to take the system on one hand, and we want to take the desired behavior on the other hand. And we actually want to compare. We want to check if the software adheres to the desired behavior. And either we find a bug, we find a situation of the program which indicate a bug, or we get a mathematical proof of correctness. And this is, again, it goes back to Turing, actually. It goes back to very old ideas in computer science. But there are, yes?
How do you define the desired behavior?
So we will see later in the talk. But that's a very interesting question. Actually, a biggest problem in computer science, one of the biggest, and there are many articles, is what is the desired behavior? And we'll show you, I'll have some answer to that. That's a great question. But even if you can define the desired behavior, the idea is that from computational, it's a computationally hard problem. So in fact, comparing the required behavior to the desired behavior to the system is a hard question. And the question, how do we solve this hard question? I'm going to talk a little bit about it in the talk, and there are more material that I'll be happy to distribute. So what we do, As a company, we are doing two things. So we are hoping to do two things. One of them, we actually develop technology. The technology assumes that you have some kind of a required behavior, and it takes the code, and I'll give you a demo later. But the idea is it compares, and it finds errors. And the interesting thing, it's a technology which is exact, in a sense that each of the errors which are found are real, and in fact, it can find all errors. Okay, so it's exhaustive technology, and we can talk about it later, and I will explain you why. But the second thing that we do, we address your question. What's your name? Graham. We address Graham's question. We are trying to define what is the required behavior. And that's a very interesting question, and we have partial answers for that. Okay? So one answer is that we have some generic properties. We have some properties which must be correct for all programs. Okay? And these are the properties that we check. And I'll show you later something very interesting, which is a generic property that we check. And this property it does not guarantee correctness, but for example, it avoids the DAO, it avoids many of the bugs. So that's one thing that we do. We contribute generic property, and here I say I take credit. Actually, this result is by Shelley Grossman. She's part of the company, and actually this is her result. And they are published in a paper in Popel. This is a principle of programming languages. You are welcome to find it, and I can also send it to who is interested. So we define what's correct. And I should say, by we, the community define what's correct. So for example, ERC20 is a standard for minting a new token. So every time you mint a new token, you check, for example, that the balance is maintained. So these are generic properties, but we can think of also of contract-specific properties. And this relies on the programmer to define them. Okay, so something specific to the programmer. For example, I have a wallet, and the wallet should have sufficient number of signers. Okay, does it answer your question partially?
Yeah, I mean, do you take that behavior in code, or is it like a level higher in terms of like user stories?
You can actually define it in code. You can define it in a cert. We will see later in the video. You can also define it like this kind of things. We can actually automatically generate it from kind of high-level specification. Okay. More questions. Okay. So far, I should say the tool has not been released. We will release the tool soon. But we work actually with one customer, which is lovely. This is a company in San Francisco called Compound Finance. What they are developing money market on top of Ethereum. And they actually, we didn't give them our tool. We basically, Shelley and David Deal, who is a professor from Stanford, they took their English specification and they converted it into our tool, and they run it. And the interesting thing to notice that actually we find bugs. And that's not surprising, because specifically we find corner cases. We find cases which are really hard for humans as experts as are to find. And another thing perhaps which is interesting, that actually there are some problems that they were worried about, and we can show them, since the technology is exhaustive, we can show them that they can never happen. Because we show them that in fact it satisfies the specification that they care about. Okay? So I want to give you sort of an interesting idea of what is a correctness property for contract. Okay, so here I'm going to be a little technical. Please stop me if it doesn't make sense. So I want to define some kind of a correctness property for contract. And this is a generic property in the sense that I claim, at least empirically, that all reasonable contracts have to satisfy that. Okay, so I'm going to show you code, but hopefully it's not too bad. So here is some code. You see the blue code, there is a red code, and think about it. It's like Ethereum, but I'm not showing you. It's like it will have it in any blockchain. So this is the blue code and the red code. And interestingly, you see the blue code actually calls the red code. This is kind of the situation that you can have. You can think of each of one of them as a contract. Okay? And the interesting thing in the Ethereum or in any blockchain, that this is an evolving system. Basically, contract comes and go. Okay? When I define a contract, like for example in the DAO, later on there can be another organization. You see, this is a contract written by Apple, and later on perhaps IBM contribute a contract. And later on, you see Facebook actually changed this red contract. So all of this, somehow, this is an evolving system. and we want to guarantee that it's correct. So how do we do it? Look, this is a very, very simple code, okay? I have this module blue, and there is this decrement, and this decrement, think about it, that, for example, it accepts A, and X, suppose X is your balance, and what it does, if your balance is positive, then it's decrement. Okay, and it's a very, very simple code, but it demonstrates the kind of a bug that happens in DAO and in other contracts. Okay, and this code looks like it's a benign code. It looks like it's a reasonable code. It basically checks that something is greater than A, it logs it, and then it's decremented. Okay, and this looks like a reasonable code. You would imagine that you can throw away the log, okay, because it doesn't matter. The log is just logs the value, and it doesn't matter. So we see that we prove this property. X is greater than 0 here, and now X is greater than 0 and greater than A. And this looks all good. Is it good? Does it guarantee that we can always look at it independent of the other word? Is it guaranteed to be correct? Sorry? So what? So it's still going to be OK. The idea is every time I check the value, I check that it's X is greater than 0, than A, and I reduce it. So it looks OK. OK, so it looks like I could drop the log. But in fact, it's not the case. And that's exactly what happened in Ethereum. What happened is that look at this code. I did this DEC which calls log, but log occasionally calls the DEC. What will happen in this code? What will happen in this code? So what will happen? I will execute it, and I'm showing you the execution. I start by X equals 100, okay, and I'm showing you the execution of the program. I'm showing you the stack of the program and the trace of the program. So the blue module executes the DEC 100. This calls the red module, which executes the log 100. Now the red module calls back the blue, so it executes this DEC 100 again, okay? And now the red module here called the log, okay? And it's now returns. And now when it returns, you see it executes this instruction here, X gets X minus A. So X becomes 0. And now we go back. We go back to the red module. We go back to the blue module. And then once again, we execute this instruction at line L. And the balance becomes negative. So our money is lost. Okay, our money is lost here. And this looks like a weird situation, but the idea is we have these back and forth calls that actually cost our money to be lost. And that's exactly what happened in the DAO and other cases. So we want to prevent this kind of situation. We don't want to have it because we want to have a code which is simpler to reason about. Okay, that's what we want to do. So you look, this is very strange. X was greater than A before the log, and after that, X is no longer greater than A. So something really strange happened, and it happens because of the callback, because of the fact that DEC can call log, and log can call DEC back. Okay? And you look like it's a weird situation, but in fact, it's a situation that is actually required in the Ethereum. Please ask me questions. If you want to clarify, please ask me questions. Okay. So what do we do? So in this paper, we define a generic correctness property for all contracts. And we say a contract is effectively callback free if for every time, wherever you have an execution which has a callback, there is another execution without callback. Or if you want to think about it intuitively, what it means is that you don't have to worry about callbacks. You can just ignore them. And the idea is we want to make sure that in any program that we write, this is the case. And this is nice because it will allow us to handle each of the contracts separately. My contract and your contract, I can check their correctness separately. So it's OK that the contract evolves over time. And the interesting thing, there are other tools, syntactic tools that check this thing, but they have many false alarms. We do not have false alarm, and I'll show you this empirically. Every bug that we find, at least now empirically, it is a real bug. OK, so let's again look into this thing. So you see the problem in this module is that you see I have this call and call, And this way I lost the money. Maybe I should ask you, the coder, how do you fix this code? Do you know? How do you fix the code? Solidity programmer, how do you fix the code? What's the way to fix the code? Yeah? So one way is to get a tail call, but that's not going to work all the time, because in fact, if you have many methods, it's not going to be tail code. But there is something weaker that you can do, which will be enough here. What do you have to do? Graham?
Can't you just restrict the scope of those functions, those methods, so they can't be called outside of?
No, so that's too restrictive, because I'll show you that there are many behaviors that we need for that, especially because we have local state. So you could do that, but that would be too restrictive. The community will not accept it, because there are many, because you don't have, think about it, callback, they implement kind of event-driven programming. So you do want to have the ability to have callback. So the trick is what we have to do in this case. We have to order the statement. This statement, x gets x minus a, it must be executed before the log. That's the only thing that we have to do to get it correct. Of course, it's tricky, but that's the only thing that we have to do. We swap it together, and when we swap it, it's OK. And our tool, basically, we check your property. And in fact, it's, of course, you can write what property you want. But if you don't, we can check these generic properties. OK? Yes?
A require somewhere?
Sorry?
A require somewhere?
What do you say?
A require.
No, so I'll show you later in the demo. But the idea is what we have for the tool. You have a set of user-defined, you can define your own property, and there are predefined properties. And you can select the predefined property from the list. I'll show you very soon a demo, hopefully. Maybe it will be clear. OK, so just to give you experiment, actually, this is an old data. I should give you, so basically what we did, we ran this tool, basically we ran it on all the transactions in the blockchain, because we were worried, because maybe we have false alarm. Maybe we find behaviors which are flagged as errors, and they are not errors. But in fact, this doesn't happen. We check it empirically. The interesting thing, by the way, that you see, these are all the contracts. These are the number of callbacks. There are many callbacks, but in fact, the ones which violate our property, they're all bugs. So we do not have false alarm, which is very nice. Usually, if you have syntactic tools that check your code, they can be valuable, but they have false alarm. I should say our check is much more expensive, but we do not have false alarm. OK, so how does it work? So basically what happened, we have some contract development environment. You write your smart contract, you write the properties that you want, and you fit it to our tool, which we call Certora-AEV. It's automatic exact verification. And it gives you a verification report of the properties which hold, and it also gives you a test cases which indicate the errors. So it will automatically identify, and I'll give you a demo, it will automatically identify the input which leads to the error. And the interesting thing, this technique is fully automatic. You just have to write the property, the program and the property, and you get the error, and you get actually all the errors that you get are real, in the sense that they lead to a case that the property is violated. And also, we do not miss error. That's another property. So we are actually solving a very difficult problem in computer science. So we are solving this problem. And how does it work? So the idea is, in fact, we don't work at the solidity level, because we want to be agnostic to the programming language. We take the program, for example, in Solidity. We run it by the compiler and compile into EVM, EWASM, or other representation. And then we feed it to our tool, and we find either a verification report or a test case. By the way, you do not have to trust us. The verification report that we have, it can be checked by another program. And of course, we can have bugs, but the tools will identify them. OK, so you can check the verification report that we produce. Yes?
How do you ensure that you don't have false negatives? So contracts that you flagged as correct and bug-free, how do you ensure that they're actually bug-free?
Because the idea is that we have, and I'll show you later, we have an exhaustive technology that summarizes all the behavior of the code. So in fact, and basically the idea is that I should say, when I say bug-free, I should be more careful. What I'm saying by bug-free, I'm not necessarily saying that they are bug-free. I'm saying that they satisfy the property that we define. Okay, if you define the wrong property, that's not, I cannot help you there. But when you define a property, we check all the behavior of the program which satisfies this property. Okay, so for example, you check that your x is greater than 0, then we check that all behavior x is greater than 0. Yes?
Okay, and with this, the property you check is only related to callback. So if I...
It's not related to callback. It could be, the property related to callback is built in, but you can define your own property. We'll see that. You can define your own property. Okay? You can define your own property. I'll give you more data. Yes? More questions, please. Wonderful. Yes? We will see in a second, but the idea is to think about it that you write a cert. Think about it that you write something in Solidity that actually specify like the property that you have. Sorry? Usually checking the property. So you're saying what happens if the property itself is incorrect? That's what you're asking? So the answer is if the property is incorrect, you are lost, kind of. But in fact, it's easier to actually write, and I'll show you with the wallet, whatever. It's much easier to define the property than defining the code. I'll show you coded bugs in the parity and whatever, because the property that you define is actually define something like what is happening and not how it's implemented. I'll show you that, in fact, it's easier to write, and it's in our experience so far, it's not so bad. You can define the property, and defining the property, you do not need to understand fully the code. Okay? But of course, it's the end of the day, and there are also generic property like ERC20, all of these guys, the ERC720, we take them from the community. And there it's actually, they are defined. They are actually definition by the community, and we take them and we enforce these best efforts. There was one more question, but I lost it somehow. Okay. So
we are here to show you how easy it is to ensure the safety of your smart contracts using a new tool called Certora-AEV to be available soon. Bugs have terrible consequences, especially in blockchain platforms. The tool can help you ensure correctness and increase the trust in blockchain. What is AEV? AEV stands for Automatic Exact Verification. It checks all possible executions of smart contracts. But how can all executions be checked? Isn't there an infinite number of executions? There is. Therefore, Certora-AEV has an algorithm to exhaustively check all executions without explicit enumeration. How does Certora-AEV work? Certora-AEV receives a contract, which can be written in any programming language, compiles it using standard compilers, and analyzes all executions defined by the low-level instruction code against a set of expected properties. AEV produces a report with all the properties which hold and test cases demonstrating bugs. This way, AEV provides you with definitive assurance that your contracts behave the way you intended them to behave. What properties can be checked? Let's start with an example. At any location in the contract code, the user can declare a property which must hold in all executions that reach that location.
you see that go.
This code defines the effect of withdrawing coins. The property ensures that the balance is correctly updated whenever the withdraw function is executed. The above code violates this property, so when the property is checked, Certora-AEV automatically identifies an input with the callback for which the property is violated. The developer then corrects the code by reordering the lines and then runs Certora-AEV again. The tool exhaustively checks all possible executions in the corrected code and reports that the property holds. Should I always write the properties myself? No. You can also select predefined properties from a list. The list grows continuously as we add new properties based on standards and best practices from the community. The user selects a property out of a list of useful properties. For instance, this list covers common vulnerabilities in smart contracts. More information is available at www.certora.com.
Thanks. So maybe hopefully this was more useful. How much time do I have?
You have 5 minutes, Mooly, so let's open it up to some questions now.
Okay. Yeah, because I have a lot of the technology, but tell me where you want to do, and I can explain to you. I can go like to the technology, we'll do exhaustive. Maybe you tell me a few questions because I don't want to run over time. Yeah.
So how do you evaluate the behavior of the contract? Do you use a model checker to do that?
So it's not a model checker because the idea usually model checkers are very good in finite state behavior. And we do not assume finite state. We actually reason about infinite state. So we actually have...
How do you do that?
So that's actually explained in the bottom of this slide. But can I explain that? Or? I go fast, I don't actually know how to get there. Sorry, Tony Hoare, many of the things actually were invented here, but actually you see how we find. So actually let's see this one bug. So you see actually this is actually a wallet, and you define this thing, and you see the tool actually automatically identified. Actually it's actually inspired by a code which is executed now. Okay, so maybe I skip that. I just want to tell you how do we check correctness. So the idea is, hey Sophia. So the idea is, I see some recognized picture. Yeah, so the idea is we take the smart contract, we take the front end, and we actually generate a verification condition. This is a formula that represents all behaviors. Okay, and this is actually a formula is over all, it sort of represents all behaviors. And it actually, in particular, we are looking for behaviors which satisfy the semantic of the program and violate the property. We're looking for some cases, and there we feed it to constraint solver. There are many tools, they are public domain actually. We feed it to them, and they either give us a solution which indicates a bug, or a thing that no solution which is a proof. So here's a very simple program. You see this program, and basically it has few behavior, and I want to check that x is equals to y. So you see that the tool actually generates a formula that represents all behavior, and then automatically, and that's how we found the bug in the tool, automatically we identify the input which leads to the error. So automatically we find that, and once you fix the error, we can actually generate a proof for you. It's not going to be necessarily a pretty proof, but it's a proof that you can check by a machine. Okay, this makes a little more sense to you, hopefully. I can talk to you later, maybe. More questions? Yes?
Intention to have it running in real time in the IDE, like in the video we just saw.
Yeah. Ideally, what we want to do, we actually want to sit on the blockchain, and every time you upload a new contract, we want to check it. And also, every time you upload the new property, we want to check it backward on all the contracts, because maybe we don't know actually what property is checked. And later on, we get some report from the community, and we want to check it. So we want to make it like a tool that will be hopefully a continuous tool, that every time a contract is uploaded, we check it, and every time a new property is uploaded, we also check it. But at the moment, it's a tool that works on a single contract.
And how many seconds does it take to check a typical contract?
So it actually depends on the size. So far, we have experience with medium-sized program, and it takes seconds to minutes. But when we go to larger one, it's a hard computational problem. I assume it could be 10 minutes, but it's still better than a human.
How many lines is medium?
Medium in solidity is a 1,000 lines, I think, right? Yeah, that's what there are more solidity experts than I am, but I think that's a 1,000 lines. Yeah. Thank you, Sophia. Yes.
Is this meant to be used in conjunction with test-driven development and unit tests, or is this?
Yeah. So one thing that we are thinking is just basically give this as a free tool for a developer to just try it as a developing environment and integrate it into Remix and other environment so that you run it and you check the property.
I mean, in practice, as a developer, would you still be doing your normal sort of test-driven development?
Test development is wonderful, but the idea is here, what it does, it automatically identifies for you test cases which violate the property. And an interesting thing that we do when you work with this kind of system, and of course we are not the original one, there are a lot of systems like that, you find out that sometimes you have a bug in the code, and sometimes you have a bug in the property. And when you have a bug in the property, of course, if the tool tells you that it doesn't violate, so you understand, in fact, that you have a bug. Because for each of the code that we have, when we tell you that the property holds, it is guaranteed to hold. Okay, so some of the usage of this tool, and this tool you can also use to do some other things, like path exploration or other things. Yes?
I mean, this is a business question, but if this tool currently exists and can do what it can do, I mean, there's money on the table. So you could look at every single contract out there at the moment that's holding funds.
That's what we are trying to do. Come and explain to us how. Because that's exactly what we are trying to do. We are trying to understand what is that's why we are academics, but we are trying to, our understanding of business is a bit limited, but this is exactly what we are trying to understand. What will be the commercial value of such a tool?
I mean, on that legally, what do they say? I mean, are you legally allowed to steal funds from a smart contract?
So we're not going to do that. This is not what, we're not going to be, it's nice to be Robin Hood, but I think I lost my chance. I'm too old for that. So I don't think I can be Robin Hood. Maybe Shelley or the other younger guys in the team. It's nice to steal from the rich and bring to the poor or whatever. It makes sense, but I'm not going to do it. But you are absolutely right. Also, I should say that when we find an input, it's an input to violate the property, for example, in the Dow case. But it's not necessarily an input that you can use to steal the money. But interestingly, actually, you can use this technology to help you there too, but I'm not going to talk about it. So you actually could use this tool in a better way somehow because when you find a bug, you are looking for a case which is actually violate the property, but maybe violate the property in a sense that you can, for example, maximize the number of things that you can steal, perhaps, or something like that. Yes? So the tool actually verified the bytecode level. We decided it's a design decision that we want because A, it's somewhat easier for us, and B, we don't want to trust the compiler. But I should say that, in fact, in order to get meaningful errors, when we find an error, we actually do use the compiler in order to go back and give you because we want to give you the error messages understood for a solidity. So we do actually call the compiler, and actually we use data from the compiler in order to produce meaningful errors. Yes?
I believe that in your video, when you corrected code is actually wrong because you are sending zero.
Sorry?
You zero out the value before you send this out. So
We have to check it. I will check it. Thanks a lot. I will check it. I'll check it. Thanks a lot.
Okay, thanks very much for that, guys. It'll be a round of applause. Really take it. One more question from me. When is this going to be available?
So hopefully we are thinking of something 2 to 3 months to have a trial version that you can try, probably as an SAS service, something that you can just run your contract, put it there, and try. But we are also looking for volunteers to work with us, maybe send us contracts that we see the understanding, especially if there are interesting contracts that have something more interesting. We are really happy to hear, but we will release it to the public very soon.